Good morning, welcome to the chemistry online classes. In our last class, we have discussed about the few of the important terms which are used in the coordination compounds. In today's class also, we are going to discuss about the one of the important bit of the topic, that is regarding the ligands. Okay, as you know, the coordination compounds consisting of the central metal atom as well as a ligand, and the ligands will going to donate a lone pair of electron towards the central metal atom in order to form the coordination compounds or the complexes. So ligands, we are in today's class we are going to discuss about the ligand. Ligand will going to donate the lone pair of the electron towards the central metal atom. Those are nothing but ligands. So let us go for the definition of the ligands. What are ligands? Ligands are the ions or the molecules which can donate one or more pair of the electron towards the central metal atom or ion to form the coordination complex. Okay, that only we are going to write. Ligands, these are the ions or the molecules which can donate one or more pair of electrons towards the central metal atom or ion present in complex compound. Okay. So ligands are the ions. Let me tell you, see, suppose this is the complex which we are talking about, and this is the coordination sphere which is present inside the square bracket, and this will be the metal and this will be the ligand. So what is ligand? Ligand is the ion or the molecule which can donate one or more than one pair of the electron towards the central metal atom or ion present in a complex. Okay, present in a complex compounds or coordination compounds. Then example for the ligand you can take NH3, H2O, Cl minus, Cn minus, all these are the example for the ligands. It means these have the tendency to donate the lone pair of electron towards the central metal atom. So the ligands are classified depends upon the ligating atoms present in those molecules. The classification of the ligands based on the ligating atoms present in their molecules. So let us discuss about the types of ligands. Types of ligands. Okay, the ligands are classified on the basis of what? On the basis of the ligating atoms. Okay, and then the first classification is monodentate ligand. Monodentate ligand. The name itself indicates mono means one. These are the ligands which can donate one pair of the electron, only one pair of the electron to the central metal atom. Those are nothing but monodentate ligand which can donate only one pair of the electron, only one pair of electron. Such type of the ligands are called as monodentate ligands, and these are having only one donor atom. It means a donating atom will be only one. That's why these are also called as unidentate ligand. These are also called as, this is the first point. Second point is these are also called as unidentate ligands. These are also called as unidentate because these are having only one of the donor atom, that is why these are called as unidentate ligands. And these monodentate or unidentate ligand may be positively charged, or those may be neutral ligands, or those may be negatively charged ligands. For example, see here neutral ligands, these are the monodentate, it means which can able to give only, which are consisting of the one of the donor atom, which can able to give only one pair of the electron to the central metal atom or ion. And here these monodentate ligands may be neutral ligands, or they may be negatively charged ligands, or they may be positively charged ligands. So, example for the neutral ligands are amine, that is NH3. This indicates which can able to, this is the coordinating site, it means through which it will going to attach with the central metal atom or ion, we can say. And it is a H2O, that is aqua, and this one is carbonyl, and this one is nitrosyl, this one is pyridyl, and the negatively charged ligands are cyanido, Cn minus, okay, and these are the lone pair of the electrons which I am showing that can be donated to the central metal atom. And here it is a chlorido, here SCN minus is there, means cyanito, that is thiocyanito, and then acetate, and then hydroxo. All these are the example for the negatively charged ligands. And some of the positively charged ligands are also there, like nitronium, and then nitrosonium, and hydrazinium. So, all these are the example for the monodentate ligand. Clear? So, this is the first class of the ligand, depends upon the number of the ligating atom. It means here only one of the ligating atom, that is one of the donor atom will be there. These are nothing but monodentate ligand. Second category is bidentate ligand. Okay. These are the ligands which can able to donate two lone pair of the electrons towards the central metal atom. Two lone pair of electrons. These can able to donate the two lone pair of the electron towards the central metal atom or ion. Such a type of the ligands are called as bidentate ligands, or else you can say these are consisting of the two donor atoms. These are having the two donor atoms. It means one of the donor atom can donate one pair of the electron. One donor atom can donate one pair of electron, one more donor atom can donate one more lone pair of electron. It means totally two lone pair of the electron is donated by the ligand. Such a ligands are called as bidentate ligand. Example here oxalato. See here CO minus, here these two CO oxygen, these two will able to donate their lone pair of electron. It means two lone pair of the electrons are available, two donor atoms are present here, that is why it is called as bidentate ligand. And one more example is ethane 1,2 diamine, that is shortly called as EN, ethane 1,2 diamine. And one more example is DMG, its short form is DMG, and its expansion is dimethyl glyoxime ligand, and the structure will be like this: CH3 CN double bond OH, and for this carbon one more unit is attached, and here this is DMZ, that is the bidentate ligand. And one more bidentate ligand is glycinato, that is shortly written as ZLY. And then here also here also the two lone pair of the electrons are donated. It means two donor atoms are present there. That is why it is also called as what we can say bidentate ligand. And here this is ethane 1,2 diamine as well as DMZ, both are symmetrical ligands, we can say. So this is how we can explain about the monodentate and bidentate ligand. Once again I will tell you what is ligand. Sometimes one more question will be there, what is ligand, or give what do you mean by bidentate ligand, such a questions will be there. And what is the definition of the ligand? These are the Ions are the molecules which can donate one or more pair of the electron towards the central metal atom or ion present in a complex compounds or coordination compounds. And then the ligands may be, it may be, those may be, you can give any example like aqua, water, Cl minus, Cn minus, any example you can able to give. And then depending upon the number of the ligating atoms, I am telling repeatedly, depending upon the number of the ligating atoms, the ligands are classified into monodentate ligand, bidentate ligand, tridentate ligand, polydentate ligand. Okay. And then first of all we are discussing about the monodentate ligand. Monodentate ligand means these are the ligands which can donate only one pair of the electron, only one pair of the electron towards the central metal atom or ion, those are called as monodentate. Or else you can say that it consisting of the only one of the donor atom, that is why these are also called as unidentate ligand. And these monodentate ligands may be neutral, those may be positively charged, those may be negatively charged. And example for the respective neutral ligand, negatively charged ligand and positively charged ligand I have written, and you may note it all these ligands, that is example for the monodentate ligand which are positively charged, which are negatively charged, which are neutral also. Clear? So let us go for the one more, that is bidentate ligand. Bidentate ligand is, these are the ligands which can donate two lone pair of the electron towards the central metal atom or ion, or these are consisting of the two donor atoms. Here the donor atoms will be 2 and the respective examples are given here, that is oxalato ligand and ethane 1,2 diamine and glycineto as well as DMZ. Okay. So these are the bidentate ligands. Similarly we have tridentate ligand, and like this it goes on up to, if the ligands are more than 2 means that is said to be a polydentate ligands. So as I said you, monodentate ligand, bidentate ligand, similarly tri, so on up to polydentate ligand. Polydentate ligand means these are the ligands which are having the several number of the ligating atoms which can donate several number of the lone pair of the electron towards the central metal atom, or you can say more than 2, like that you can say. These are having several number of ligating atoms, and this can able to donate several pair of electron to the central metal atom in a complex. Okay. So we can say that polydentate ligands are the ligands which can donate several number of the lone pair of the electron towards a central metal atom which can having the several number of the ligating atoms we can able to say. And example for the polydentate ligands are, see here, EDTA 4 minus. EDTA means ethylene diamine tetraacetato, ethylene diamine tetraacetato. See here, ethylene diamine tetra 4 acetato. Okay. So this is the ligand which acts as a polydentate ligand. It means which can donate several pair of the electron which are having the several number of the donating atoms I am telling you. See here, totally in this complex there are, in this ligand 6 ligating atoms are there. 6 ligating atom means 6 atoms can donate lone pair of electron. In that 6, 4 ligating atoms are oxygen and other 2 ligating atoms are nitrogen. So totally 6 atoms can be donated by this ligand, that is why it is also called as hexadentate ligand. Hexadentate ligand, hexadentate ligand. See here, ethylene diamine tetraacetate ligand. It is a hexadentate ligand because there are totally 6 ligating atoms will be there. In that 6, 4 will be 4 oxygen can able to donate its lone pair of electron and 2 nitrogen can able to donate its electron, lone pair of electron towards the central metal atom. Similarly, you can give one more example, that is EDTA 3 minus. Okay, it means ethylene diamine triacetate. Only 3 means triacetate will be there. See here, 3 acetate group like this, 3 groups. Here it will be a 4 groups. So this is the structure of EDTA 3 minus and it acts as a penta. It means 5 ligating atoms will be there. 5 ligating atoms will be there, and that's why it is called as a pentadentate ligand. And you can just think about which are those 5 ligating atoms. As I said you here 4 oxygen and 2 nitrogen, but in case of this one, which are those 5, you have to just think on it. Okay. So this is regarding the polydentate ligands. So let us go for the ambidentate ligands. Ambidentate ligands means which can ligate through 2 different atoms. It means these are the ligands which are having the 2 ligating atoms. It means we can, let us go for the example, I can explain it clearly. So ambidentate ligands are the ligands which can ligate through 2 different sites or 2 different ligating atoms. See here, example for the ambidentate ligand means nitro. It means nitro. In this nitro ligand, it can ligate either through, it can the coordinating site. It means the lone pair electron donating site may be nitrogen or it may be oxygen. Sometimes it can donate through nitrogen like this. This is the metal. For the metal, lone pair of the electron is donated by the nitrogen. Okay. Even it can coordinate with the central metal atom by oxygen also. It means this is the ligand which is having 2 ligating atoms. Such a ligands are called as ambidentate. Or one more example is thiocyanito. Thiocyanito, its SCN minus is the ligand, that is the what we can say ambidentate ligand. It means it is having the 2 ligating centers or sites. One, it can donate its lone pair of electron from the sulfur also, from the nitrogen also, but both cannot be done at the same time. Okay, one of the site can able to donate its, it is having 2, exactly it is having the 2 ligating sites, but when it is coordinating in any complex, one of the site can be donate the lone pair of the electron. Such a ligands are called as ambidentate. So what is the meaning of ambidentate? These are the ligands which can ligate through the 2 different atoms. So those are called as ambidentate. And the last one is chelating ligand. So what is chelating ligand? Usually the chelating ligand is formed by the bidentate or polydentate ligands. These are also having the several number of the ligating atoms, similar to that only. Several number of ligating atoms will be there. Several number of the donor atoms will be there. Ligating atoms are donor atoms. So we can say it can donate more number of the lone pair of electron. That is several lone pair of electron towards the one central metal atom. See here, example for this is oxalato. Oxalato structure will be like this. Here the oxygen, these 2 oxygen can ligate through the central metal atom. And see here, such a complex which is formed when chelating ligand is going to be formed. It means it consisting of the several number of the ligating atoms. Here several number of the lone pair of the electrons is donated to the central metal atom. During that time, which complex is formed, that is called as ring complex, or these are also called as chelates. These are also called as chelates. And the number of such a ligating group is called as denticity of ligand. It means a number of such a ligating groups. How many ligating groups are present there? That is nothing but denticity of ligand. So example here is oxalato. Two oxygen can able to donate a lone pair of electron towards the central metal atom. See here, when these two can able to donate the central metal atom, there is a formation of the ring. Just you look at this, see here, it is a ring formation is there. It means it will be like this, yes or no? These are the carbon, you can think here, carbon, oxygen, oxygen, it can able to donate the metal here. So 5-membered ring is formed. 5-membered ring is formed. That's why ring complexes. Normally, such a type of the complexes are more stable because these can able to form a that is ring structure. It can able to form the chelating complexes are more stable compared with other complex. Because of this reason only they can able to form 5-6-membered rings. That's why the chelating complexes are more stable as compared to other complexes. And one more example is ethane 1,2 diamine. Here also, as I said you, this is the again bidentate ligand. Okay, so I said you the chelating ligand is, that is the chelating complexes are formed by the bidentate and as well as polydentate ligands. And here also it will going to form a 5-membered ring. Just you look at this here, 5-membered ring is formed. That is EN, that is ethane 1,2 diamine can also form the 5-membered ring. That's why the chelate complexes are more stable as compared with the other complexes. So till now whatever we have discussed, that is all regarding the ligands, and these are the terms which are very important. Just you note down whatever I have written on the board, and examples along with their structure you need to know. And sometimes they will going to ask you 1 mark, that is 3 marks is splitted, like 2 plus 1 or 1 plus 1 plus 1. During that time they might be ask you definition of the ambidentate ligand or example, like that questions will be there. Okay. Further we are going to discuss about the nomenclature of the such a coordination compounds, and certain rules are there that we are going to discuss in our next class. Until that, keep watching the video and make your own notes by looking at the video. Okay. Thank you.